Voice clear? Audio okay? Everything is okay. Laptop problem nowadays, I removed it. Okay, now start. Actually, yesterday, this all conditions should have been over, but because of problem, half an hour delay, and little later, because of your problem, I will tell you, I told you, not responding properly. Okay, leave it. See, first, just a minute. I just put a small boundary line here so that I don't have struggle. Okay, up to here no problem. Here, just to be on safer side. Okay, no problem. Now space is defined. I should work within the space only. Later, next time when I order the board, I will see that length and width are matching. If length and width are matching, I can use I don't have to worry about it. See, now make a note, already over. See, I'll write here, everything is over. See, I'll first write here, a beam. There is a beam of total length L, right here, total length L. Now, I will put summary once again. See correctly, total length L, very important, total L. By chance, it is simple support at the ends. For example, in a building, a floor beam is there. At the end, columns are there. But actually, if columns are there, it becomes rigid joint. If rigid joint is there, some reacting moment will be there. Just ignore it. Simply support it. See, column is already cast. You are placing the beam with reinforcement, not column reinforcement, beam reinforcement, not what? Embedded inside the concrete. Or you can do one thing. Say timber beam or steel beam supported by walls. So that we do not want beam and column to be monolithic. We want simple support. See, basic is always simple support. Later, if reacting moments are there, then automatically end moment will come. That will hog. That you learn later. When you study systematically, simply supported case. See, L. Suppose you support at the ends. I'll put in the per side. See, total length is L. See correctly now. Total length L. Suppose you make a simple support at the ends. Apply only UDL. Then the beam will heavily sag. Hog from this side. This is the bending moment diagram. You will have maximum bending moment here. This bending moment equal to W into L square by 8. Huge BM will come. Correct or not? Very huge BM will come. Clear? You will have a very huge BM. Okay. Now, this BM we do not know how much. I will randomly put a value. Don't check the numerical value. Sometimes people will tell, you change the loading, change the span. Now, values are not tallying. I will tell, keep quiet. Don't. See, red color values are wrong values. Say, imagine 200 or imagine 400. Okay, just for understanding. Do not check the values. 400. Now you should design the beam for a maximum BM of 400. See, so designed BM will become 400. Heavy BM. Now, you can go for economy. How? Provide overhangs. Instead of providing support here, bring the support inside. See, same span, same length. See, this way and this way. Now support, see, this I will call AB. AB is support. I will shift the support A here, B here. Now, so I won't call AB here now. See, Now, ends I will make CD. Apply the UDL. Put a small overhang. Now, this is the span L. Overhang is A. Overhang is A. Now the BMD will become, what will happen? Tell me. This 400 will reduce or increase. Tell first. This 400 will reduce. I am putting not a big overhang, medium overhang. Small, quite small overhang. This 400 will increase or decrease. It will reduce. Maybe the 400 will now come down to, say for example, this. Now the bending moment equal to WL square by 8 minus WA square by 2. So then maybe, but here some hogging BM will come, small value. See, BMD will come this way. See, this way. Okay, now imagine this value is not 400, 300. If that is 300, then most probably this will be 100. Imagine 100. Okay, 100. How much is bending moment? This bending moment is permanently WA square by 2. Same. Now, the bending moment we reduced. Now, you should design the beam for a maximum BM of not 400. Tell how much? See, correcta bandila? Little odd. No problem. Those things all I take care. But even then, it hurts a little. See. Now, this is sagging. This is hogging. Now you should design the beam for what BM? Tell me. 300. So design BM reduced or economy. Now that way, if we continue, this is small overhang. Suppose you see, increase the overhang further and decrease the span between support. Move the supports inside little more and a little more. Okay. Then one particular value is there. Some A, some A, some L. Now, in Jagaila, I should see available space. What will happen? Hogging BM will increase, sagging BM will decrease. Or for example, now if I draw bending moment diagram, see, the sagging BM will become from 300 will reduce to 200. Answer is same. Reduce to 200. That is same. WL square by 8 minus WL square by 2. Hogging BM also will become 200. This also 200. This also 200. Now the BMD will come this way. Okay. Now the this is the special case. This is a special case. We are going to discuss it later. Now, you should design the beam for a maximum BM of how much? Now you should design the beam. Even now, there will be hogging in the end portion and sagging in the middle portion. But sagging reduced, hogging increased. Now you should design for what BM? Maximum BM. 200. Okay. Now, by chance, you got a taste of reducing BM. Ase, durase manushanige. Hey, as I increase the overhang, this BM keeps on reducing. If you do that way, and if I provide little more overhang, same, I increase the overhang furthermore, and lesser span. Now the BMD will come. What will happen? This 200 will reduce. Maybe it will come to 120. But suddenly, the hogging BM, tell what will happen? The hogging BM from 200, what will happen? From 200, the hogging BM will, sagging BM will reduce. What about hogging BM? It will increase. If it is 120, this will become 380. That will reduce to 120, this will become 380. Therefore, once again, see, design BM 400, design BM 300, design BM 200, again design BM. Tell me, now sagging portion is lesser. Now tell me, design BM, you should write yourself only. Design BM, DBM 400, design BM, DBM 300, design BM 200. Now design BM, how much? Suddenly, like what? Medicine, that cause for which you give medicine, that is curing it. But side effect is overtaking now. How much? Once again, 300 means once again you are going away from the economy. One unique value. Therefore, this is a special case where what? Sagging BM maximum equal to hogging BM. This is the most economical case. Most economical. Clear or not? Most economical. Clear or not? First. This is the most economical case. Provide the overhang so that what? Sagging, hogging both are equal. Now, by chance, if you further increase the BM, see, I'll tell you here. Further increase the overhang, further move here, a stage will come when this 380, oh, is 380 all ido. This is, sorry, this is not 380, this is 280. Oh, I think it is 280. Again increases 280. See, remember now, next. A stage will come for one particular value. This will become 400. This will become 400. This also will become 400. And this will become 0. This all we discussed. That is special case. Now design BM is 400. Or if you further increase the overhang, I'll put here, what will happen? Then if you further increase the overhang, then this will become not 400, it will go further more. It may become 500. Sumne tamashege. This will become 500 and side effect is too much. BMD will come this way. Here also negative. Now this value is WA square by 2 minus WL square by 8 negative. Okay. These all we discussed. Tell yes or no. This everything is discussed last time. Now, see, there is no overhang here. Here, negative, positive, both are there. Here also, negative, positive, both are there. Here also, negative, positive, both are there. Here, 0. Therefore, tell the condition for this case, and also for this case. For all these three cases, tell the answer. Overhang A should be less than, for getting central BM to be sagging, we want WL square by 8 more than WA square by 2. It is lesser, no doubt. For all these three cases, that is, or you can tell there are points of quadriflexure here, which is slowly moving inwards. See, moving inwards. So, for end portion to hog and middle portion to sag, condition is A should be less than how much? L by 2. If I compare here, L by 2. Or if I compare A with the full length, A should be less than. Both are same. If you compare A with the span, A should be less than L by 2. If you compare the overhang with the total length, A should be less than how much? Not L by 2. This I will give an example for you. What is that percentage? I will tell you now. It is not L by 2. Mathematics. Here, if you compare the overhang with the span between support, overhang should be within L by 2. Or if you compare the overhang with the full span length, L by 4. Both are same. L by 4. Capital L. Capital L by 4. Full length 1/4 or central supported length half. For this unique case, you know that A is exactly equal to L by 2. Remember, for this unique case, for 0 BM here, A should be L by 2, or you can tell A equal to capital L by 4, 1/4, full 1/4. Okay. Here, for this case, tell the answer, your A should be more than what? For this case, your A should be more than For BM, nowhere to sag. Overhang will hog, even in the between supports also hogging. No sagging. If it is RCC, see, if it is RCC, here you require top reinforcement, here you require top reinforcement, here you require bottom reinforcement. Why? Hogging means top tension. Top tension. So for all these cases, if it is RCC, reinforcement is top steel and bottom steel. But for this case and this case, you require reinforcement only at the top, no bottom steel. Nominally you can give. There should be, A should be more than L by 2, or you can tell A should be more than L by 4 of the total. These all we discussed earlier. So remember, there are two parts are there. Part 1 with this one right here. Part 1 over. Part 1 over. Remember, part 1 is ratio of overhang to either span between supports or with respect to full length. So that for what ratio hogging, sagging both are there. For what ratio? But hogging is there, center of the span, bending moment is 0, special case. And for what ratio? No sagging, full beam will hog. Even center also will hog. You can remember this way. Now do one thing. In this part 2, now come to, you should write. Now go to part 2. Part 2 is nothing but a particular case of part 1. Part 2 is a particular case of part 1. Part 1, when A is less than L by 4. When A is less than L by 4, that means hogging and sagging both are there. Hogging, sagging both are there. You should write all this one. Hogging, sagging both are there. But what? But maximum hogging BM and maximum sagging BM both are equal. Clear now? Both are equal. Or you can tell the maximum BM is minimized. ಕನ್ನಡದಲ್ಲಿ ಆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬಿ ಎಮ್ ಎಷ್ಟು ಕಮ್ಮಿ ಆಗುತ್ತೋ ಅಷ್ಟು ಮಾಡ್ಕೊಳ್ಳೋದು. ಹಿಂದಿಲಿ मैक्सिमम BM को जितना हो सकता है उतना कम कर देना. English, maximum BM is made as much as possible least value, that is, you can tell, the most economical. Clear now? Therefore, that is nothing but, nodi, what? This case, that is this case. So remember, even now your A is what? Less than L by 4. If A is more than L by 4, sagging will not come. Full clear? Fast. Okay, now come to that one. Okay, now come to that one. Then I will go for a numerical. So that for practice purpose, I will go for a numerical for you. That will help you a lot. Okay, now see, start. Now write part 2. Part 2 of the standard case. It is nothing but a special case of part 1. Part 2, that is same case. A beam of total length L, between support L, overhang A. These all I cannot tell every day. Random agi. Overhang is A, between support is small l, full length is capital L, subjected to UDL, supports are A and B, ends are C and D. For this one, A relation or ratio, anything will do. Relation between A and L, ratio of A to L or A to A and capital L, both are same. Yeah, I will tell you an example of this one, practical example, bit later. Which one? Money matter. Money matter means doubt will not come, no doubt. It will be more clear to you than me. Student will tell, sir, idu chennagi artha aitu. Okay, now start. Now we want bending moment diagram to be like this. Itara. Or sorry, baritinga, I write here only. Shearing port diagram not required. Bending moment diagram. Nodi idu baritini. Hogging, here sagging. See, today's class, this is the point A, this is the point B, this is the point E, this is counterflexure O1, counterflexure O2 point, negative, positive. So many people have seen, they tell in the class that when overhangs are there, so many learned people they tell. See, overhang will hog and beam between support will sag. Wrong statement. Overhang will hog. The hog will continue for further more distance. From here, the hogging will continue for further more distance till the point of counterflexure. Sagging will be only between the points of counterflexure, not A to B full will sag. Steady. Hog, steady. Remember now, it means what? Beam is like this. This is a technical matter. So many make the mistake here. It is hog, still hog, stop. Hog, still hog, stop. Then sag. Illi. So A to B full length between support cannot sag. A to B full length cannot sag. Why? When the BM is hogging here, it will continue for some more length till it becomes zero, counterflexure. Then hogging will change over to sagging. Clear? So many people, what they tell is, see, overhangs are hogging, beam between support is sagging. No, it is wrong. You should tell overhangs are hogging, center of the beam is sagging, okay. Or if the length is 10 meter, entire 10 meter will not sag. Maybe 7 to 8 meter, depending upon how much overhang. If the overhang is too much, it is possible only center 1 meter will sag. Where is, see, only central 1 meter will sag. Over. Or if further overhang is more, it is possible that, no, it can be zero there. If overhang is further more, then sagging will not come in the span. Now, these all make a note. Clear? I will not tell again and again. ಒಂದು ಕ್ಲಿಯರ್ ಹೇಳ್ಬಿಡಿ ಸಾಕು. ಹಳೆ ಕ್ಲಿಯರ್, ಅಲ್ಲಿ ಏನೋ ಕ್ಲಿಯರ್ಗಳಿದೆ. ಕ್ಲಿಯರ್ ಆಯ್ತಾ? ಈ ಕಾನ್ಸೆಪ್ಟ್ ಹಳೆ ಕ್ಲಿಯರ್ ಅದು. ಕ್ಲಿಯರ್. ಓಕೆ. ನೌ ಕಮ್ ಟು ದ ಕೇಸ್. ಐ ಟೋಲ್ಡ್ ಯು more. Now you know that this bending moment is WA square by 2. ಇದು ಅಷ್ಟೇ. WA square by 2. This bending moment is WL square by 8 minus WA square by 2. Now, right here. After all the story, right? Therefore, for maximum sagging BM to be equal to maximum hogging BM, so that the maximum BM for entire beam is minimum possible. ಕನ್ನಡದಲ್ಲಿ ಎಷ್ಟು ಕಮ್ಮಿ ಆಗತ್ತೋ ಅಷ್ಟು, ಇದರಿಂದ ಕಮ್ಮಿ ಮಾಡೋಕ್ಕಾಗೋದಿಲ್ಲ. और हिंदी जितना हो सकता है उतना कम, उससे कम फर्दर कम नहीं कर सकते. और इंग्लिश आई टोल्ड यू लीस्ट पॉसिबल, फर्दर लेस इज नॉट पॉसिबल. योर कंडीशन इज योर WL square by 8 minus WA square by 2 should be equal to WA square by 2 numerically. Nodi, this value, don't put sign now, this numerical value should be equal to this numerical value, no sign. Once again required. Clear? Sign not to be used now. This term should be equal to this term. Okay, clear? Therefore, you do one thing, your WL square by WW cancels, or you can tell L square by 8 equal to, this will go that side as minus A square by 2, become plus A square by 2, plus A square by 2, plus A square by 2 will become A square, or your A should be equal to L divided by root 8. Remember, A should be equal to L divided by root 8. Or if you write decimal form, you should tell A should be equal to, this is connecting A with the distance between the supports, not full length. Tell the answer. I'll remove this one now. I'll remove this one. Or your A should be equal to, tell me what is 1 by root 8. What is 1 by root 8? You cannot get more than 0.5. Why? For sagging, hogging, both to be present, what is the condition? Overhang should be within half the L. Number, it should be within half the L. It cannot go above half the L. If it is more than half the L, sagging will not come. Number, 0.3535 or 1 divided by, calculator on agilla, 1 divided by root 8 is 0.35555. Yes, but you remember L by root 8 better, or approximately number 0.35353553 ಇರಲಿ ಬಿಡಿ ಸಾಕು, ಇದನ್ನು ಜಾಸ್ತಿ ಬೇಡ. ಫ್ಯಾನ್ಸಿ ನಂಬರ್ 353553 3553. car, if you want the number, you have to pay more money. Why? Fancy number. KA024 3553 6226 1881. Fancy number. That way. 0.35 pass mark number. Remember, if you link A with the span, you remember pass mark number. Crude method. Not nowadays pass mark number. Our pass mark number. When I was studying, tell what is the pass mark. Nowadays it is 40. No. When I was studying, tell if you remember, those who are seniors, what is the pass mark? It is not 40. How much pass mark? 35. Oh, some people know. 35. 35. Yet sometime people come to me not now, long back. They will tell, Kannadadalli, sir, 35 bandre saku sir. Hindi, sir, 10th is lag gaya to bus mere liye. Sir, at least 35. But sometime same person till after exam, sir, 75 bantu. Good. But there, so many people are there, they will tell, sir, 35. Okay, now. So, 35 pass mark, 35, continue one more 35 and reverse the number. Or remember L by root 8. This is linking A with L. Okay. Now, tell what is the maximum BM? Then, aga, maximum sagging BM equal to maximum hogging BM equal to, your formula is either WS, that is maximum sagging BM is WL square by 8 minus WA square by 2. Idu directly WA square by 2. Both are equal. Use this one only. If you use this one, W into 0.3553 L whole square by 2. What is the answer? If you want, just not an important result. 0.353553 square divided by 2. What is the number? 0.3553 square divided by 2. 0.0624. If you take reciprocal, it will come WL square by 16. Correct? It will come WL square by 16. That is half of WL square by 8. Correct now? I told you earlier 400. If you remember, tell me how much I told you. I first told if full span is simply supported 400. Then I told number how much for you? Economical one. How much I told you? When I gave example, I first took the full simply support. End to end supported. I told BM 400. Then economical design came. When number came, how much? If you remember. How much I told? Number. At the time of explaining, I told first time, let it be 400. Then I told what? If you remember, how much I told them? When I reached that critical state, I told what number? ಜ್ಞಾಪಕ ಏನಾರು ಹೇಳಿ ಬೇಗ. ವಾಟ್ ನಂಬರ್ ಐ ಟೋಲ್ಡ್? ಅಷ್ಟು ಬೇಗ ಮರ್ತೋಯ್ತಾ? ಫಸ್ಟ್ 400 ಒಂದೆ, ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಅಷ್ಟು ಬೇಗ ಮರ್ತೋಯ್ತು ನೋಡಿ. ಈಗ ಜಸ್ಟ್ ನೌ ಐ ಎಕ್ಸ್ಪ್ಲೈನಿಂಗ್ ಹೌ ಮಚ್ ನಂಬರ್ ಐ ಟೋಲ್ಡ್. ಫಾರ್ ದ ಎಕನಾಮಿಕಲ್ ಕೇಸ್ ಸಾಗಿಂಗ್ ಹಾಗಿಂಗ್ ಟು ಬಿ ಈಕ್ವಲ್. ಸೋ ಫಾಸ್ಟ್ ಯು ಫರ್ಗೊಟ್. ಈಗ ತಾನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಐ ಟೋಲ್ಡ್ 400 ರೆಡ್ಯೂಸ್ ಸಡನ್ಲಿ ಅಗೈನ್ ಇನ್ಕ್ರೀಸ್. ವೈ? ನೋ ಕಮೆಂಟ್. ನೋಡಿ, ಆನ್ಸರೇ ಮಾಡ್ತಾ ಇಲ್ಲ. ಎನಿ ಪ್ರಾಬ್ಲಮ್? 300. ಹಾ ಸಾಹೇಬ್ರೆ 300? ಐ ಟೋಲ್ಡ್ ಎಕನಾಮಿಕಲ್ 300. ఇప్పుడు 300 ಹಾಗಿಂಗ್ ಈಸ್ 100. I reduced further. Who told 300? Who told 300? Just now I explained for you. Full span simply supported 400. Then the most economical case came when the maximum BM, sagging, hogging both are equal. How much I told? Must ಬೇಗ ಮರ್ತೋಯ್ತು. I told 200. If you remember, ಅರ್ಧ. So remember, it is WL square by 8 ಅಲ್ಲ, ಇದೇನಿದೆ WL square by 8 is how much it is? This is WL square by 16. Clear? That is half of WL square by 8. Clear now? See, if the overhangs are not there, you write here, if the overhangs are not there, bending moment is WL square by 8. If you provide proper overhang, the WL square by 8 BM can be reduced to 50%. How much? Because 1 by 16 is half of 1 by 8. So, if this BM is WL square by 8, by providing overhang equal to what? L by root 8 or point pass mark, reverse pass mark of L, you can reduce the BM to what? WL square by 16. Clear now? To WL square by 16. Okay. Now, if you further increase the overhang, what will happen? If you further increase the overhang, ಆಸೆ, ದುರಾಸೆ, ಕನ್ನಡದಲ್ಲಿ ದುರಾಸೆ, ಅತಿ ಆಸೆ, ಕಮ್ಮಿ ಮಾಡೋಣ ಅಂತ ಹಿಂದಿಲಿ ಶಬ್ದ ಬರ್ತಾ ಇಲ್ಲ. ಆಸೆ, ಐ ಡೋಂಟ್ ನೋ ಹಿಂದಿ ವರ್ಡ್, ಐ ಆಮ್ ನಾಟ್ ಗೆಟಿಂಗ್. ಬ್ಯಾಡ್ ಇಂಟೆನ್ಷನ್, ಹೋಪ್ ಟು ಗೆಟ್ ಗ್ರೀಡಿ ಇಂಗ್ಲೀಷಲ್ಲಿ. Further increase the overhang, then it will again, sagging will reduce. Tell me, which will increase? Sagging will reduce, but which will increase? If you become greedy, sagging will reduce, but which will increase? Our disease will be cured. Side effect will become more. Sagging will reduce, no doubt. Tell me, hogging will increase. Means what? What purpose you took the medicine, it will cure the medicine, good. It will become, your pain will completely vanish. But meanwhile, some other problem will start. Some other problem more severe than this one. So, this is the relation between overhang A to L. Okay, now, 1 minute now. Now get the relation between overhang A to capital L. Why? Because I will tell the reason why both are required. 1 minute. I will tell the reason why both are required. Why both are required. Okay. I remove this one now. It's better. This is not required now. Once again. Now, why both are required? Because sometimes, you write a note here. Why both are required? No, sometimes they will decide the column position. Fixed. L antare. L. Fixed or wall position. Fixed. Beam is this way. Now someone told them, you do one thing, you provide overhangs here. Up to some limit, it is helpful. Tell the answer. Tell this overhang A, if you fix the L, you extend the beam further by A equal to L by root 8, A equal to L by root 8. So that hogging, sagging, both are equal. These are equal. Clear now? If you know the span between support, if the column positions are fixed, how much beam has to be extended further to reduce the bending here? Clear? Or one more case is there. Length of beam is already fixed. Length of beam is already fixed. Then that is length is L. Now you should think where to provide the support. From here, how much you have to come inside and provide the support means you link A with this capital L. Clear now? This also, if you know the distance between the support, then how much part of that inner span you have to extend the overhang. Or suppose the full length is fixed. Someone will tell, I want to cast a beam for 20 meter. Tell me, or a pile of length 20 meter to be lifted. Where lifting required? Then you have to locate the point with respect to capital L. Okay, now how to get it? Sorry. You know that what? This is L, but your basic is A equal to L by root 8. Now you know that, sorry, you remove the L, in that place bring capital L. Tell what is L equal to? Your L equal to what? L equal to capital L minus how much? Your total L equal to capital L minus. This I should not tell first of all. Waste of time explaining. Your small L equal to capital L minus ಎಷ್ಟು? ಹೇಳ್ಬಿಡಿ. ನಾನು ಸ್ವಲ್ಪ ವೀಕ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸಲ್ಲಿ. I am little weak in mathematics. Okay. Minus 2A. Or you can tell A equal to L minus 2A divided by root 8. Or root 8A should be equal to L minus 2A. Or, Anna 2A, come this side. 2A plus root 8A should be L, or A should be A into 2 plus root 8. Remember, one magic number, extra 2. Why? 2 overhangs are there. Remember that way. Equal to L. Or you can tell A equal to L by not root 8, 2 plus root 8. Fully clear or not? L plus 2 plus root 8. Fast, clear? A equal to L divided by what? 2 plus root 8. You tell clear, I'll go further. Clear. Now go for decimal. Now this you will get the number not 0.353553. Tell me, you will get a higher, don't calculate. You will get a higher number or lesser number. Fast. Don't calculate. Comment. You will get a higher number or lesser number. ಸ್ವಲ್ಪ ಹುಷಾರಾಗಿ ಹೇಳಿ, ಥಿಂಕ್ ಮಾಡಿ. When you connect overhang with the full length, the ratio number will come lesser number. ಯಾಕೆ? ಫುಲ್ ಲೆಂತ್ ಕಮ್ಮಿ. ಎಕ್ಸ್ಪ್ಲೈನ್ ಕೊಡ್ತೀನಿ ನಾನು ಇರಿ. ದಟ್ ಈಸ್ 2 ಪ್ಲಸ್ ರೂಟ್ 8 ಈಕ್ವಲ್ ಟು ರೆಸಿಪ್ರೋಕಲ್. ಎಲ್ಲಿದೆ ರೆಸಿಪ್ರೋಕಲ್? ಇಲ್ಲಿದೆ. ಎಲ್ಲಿದೆಪ್ಪ? ಇಲ್ಲಿದೆ. 0.2 ನನ್ನ ನಂಬರ್ ಯಾಕೆ? ಅದು ಆಲ್ಮೋಸ್ಟ್ ಈಕ್ವಲ್ ಟು 0.20710678 is the answer times capital L. Or you better remember what? Nodi, I told you that should be less than 0.5, this should be less than 0.25. Or you can remember one thing. See, lastly, to remember a 0.25 alla beda. To remember alla, remember, spelling mistake. Remember, spelling mistake, I am not correcting. Nodi. If, see how I am writing. If you know, see what I am doing. Between supports A and B, if you know the span L, then extend the overhang this side, extend the overhang this side by, see, extend this side by how much? L divided by how much? Tell me. if you know the distance between the support, extend the beam further either side by L by what? L, no, number beda. Number avel madಕೊಳ್ಳಿ. L by, correct number is to remember, L by root 8. L by root 8, or you can tell that is almost equal to point, pass mark, reverse mark times of L. 1. And, and suppose, I told how I told this one. Or, suppose you decided the beam already. If you, illi, L is known, this is obtained, or if the capital L is known, then from end, how much inside you have to come to provide the support. That is, you decide itara, how much you have to come from end here, how much you have to come from end here to get the support position, so that both the cases maximum BM is minimized. Now this, ಇದು overhang A. Okay, A equal to. ಈಗ now, if it is A, ಈಗ L ಬರೋದೇ ಇಲ್ಲ. Now your A equal to capital L divided by, tell what number? Not root 8. You can remember, not root 8. It should be lesser number. 2 plus root 8. 2 plus root 8, or you can tell approximately 0.20, ಯಾರು ಜ್ಞಾಪಕ ಇದೆ ನನಗೆ ಬೈ ಹಾರ್ಟ್ ಮಾಡೋಕ್ಕೆ ಬರೋಲ್ಲ, 0.2071, ಆಲ್ಮೋಸ್ಟ್ 0.2071. ಇನ್ನೂ ಬೇಕು ಅಂದರೆ 2071, 0678 times capital L. Or you can tell one thing, here overhang should be what? Should be approximately 35.3553% of L. Overhang should be approximately 35 pass mark point, reverse pass mark percent of L. Here overhang should be ಎರಡು ಒಂದೇ. Overhang should be what? Not 35, around 20.71% of full length. 25% of full length. Clear now? If you refer it to distance between the two support, it is around 35.35%. Objective question very important. If you refer it to full length, it is around 20.71%. I do not remember any of the number. 0.35 I remember somehow. This 20.2 I remember. This number I don't remember, because if I want, I will derive it. Deriving will take more than 10 seconds. So why should I by heart the number? In both the cases, your BMD will be like this, or this negative BM and positive BM both are equal, or maximum BM is made as much as possible least. Tell fully clear means I will go to some problems now. If it is fully clear, I will go to some examples so that correct grip will come. See, 823. No point in starting cantilever now without example. Better example. But one thing, when I go to example, diagram you have to draw. No one can tell now. What? Diagram we already, how much I explained how to draw bending moment diagram SFD. Everything I will give only answer for you. Thorough practice. One by one I will give the answer. You should do one thing. You better take a drawing sheet and arrange all the questions given by me in a compact form. So using some standard scale. Use some standard scale and do it. First example number 1. Now right here. Now we are going for example which will cover not only part 1, it will cover full part 1. And in the part 1, case 1, unique case of maximum BM minimized will also come now. Nodi, bari. Imagine, nodi, imagine, ankoli, imagine a beam of length, ಜಾಸ್ತಿ ಇರಲಿ 20 meter. Imagine a beam of length 20 meter over with UDL of ಎಷ್ಟು ಆಗುತ್ತೆ, say 30 kilonewton per meter. 30 kilonewton per meter beam. Now start one by one. ನೋಡಿ ಫಸ್ಟ್ಗೆ example number 1, you should write one by one. Example number 1, just imagine that, ನೋಡಿ total length, this 20 meter is the total length, full length of the beam or full length. You provide no overhang, provide for 20 meter simply supported. Worst case, tell why. Worst case, tell me why worst case. Tell why it is a worst case. The BM will be very, very heavy. You require deep beam. Correct or not? Very, very uneconomical. No hogging is there. Beam will fully sag. Heavy BM will come. Okay, then without showing anything, some maintain scale now nodi. ಇದು 20 ಮೀಟ್ರು 1 2 3 ಬೇಡ. ಐ ವಿಲ್ ಯೂಸ್ 4 ಪೆನ್ 1 2 3 4 ಆಯ್ತು ಬಿಡಿ. ಇದೇ ಥರ ಮೇಂಟೈನ್ ಮಾಡಿ. ಇಲ್ಲಿ 4 ಪೆನ್. ಓಕೆ 20 ಮೀಟರ್. ನೌ ನೋ ABCD. ದ BMD ನೋಡಿ ಸ್ಕೇಲ್ ನೋಡಿ ಈಗ ಇಲ್ಲಿರಲಿ. ಐ ವಿಲ್ ಮೇಂಟೈನ್ ದ ಸೇಮ್ ಸ್ಕೇಲ್ ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಆನ್ವರ್ಡ್ಸ್ 20 ಮೀಟರ್. ವೆರಿ ಹೆವಿ BM. ಓ ಸ್ಕೇಲ್ ಅಯ್ಯೋ ಜಾರ್ಕೊ ಈ ಥರ ಅಲ್ಲ, ಸೆಂಟ್ರ್ ಬರಬೇಕು. ಇದೆಲ್ಲ ಪರವಾಗಿಲ್ಲ ಬಿಡಿ. ಡೋಂಟ್ ಬಾದರ್ ಅಬೌಟ್ ದೀಸ್ ಥಿಂಗ್. ನೋಡೋಣ. ಓಕೆ, someone will comment ಸರಿಯಾಗಿ ಬರೋದಿಲ್ಲ ಅಂತ. ಐ ಆಮ್ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಇನ್ ದ ಸೈಡ್ ಹಿಯರ್. ಐ ಶುಡ್ ಸ್ಟ್ಯಾಂಡ್ ಹಿಯರ್ ಆ್ಯಂಡ್ ರೈಟ್. If anybody comments that way, let him come in front of me. This is directly ಎಷ್ಟು ಫಾರ್ಮುಲಾ ಬರೀ W L square by L ಅಲ್ಲ. This is a capital L. W L square by 8. Capital L come small l. See, it is capital L come small l. W L square by 8. Answer 30 into 20 square divided by 8. Full beam sagging. The full beam will sag. And for the beam, design BM equal to, answer, actually, answer 1500 kilonewton meter. If it is a steel plate girder, I think if it is a working load BM, ಎಷ್ಟಾಯಿತು 2250 into 1.1 ಒಂದು M. If you use FP 450 steel, a depth of the plate girder may come up to 1.5 meter. Huge, yes, it comes. You see plate girders all, I think 1.5 Allah, you may get the depth of plate girder around 1.75 meter with the flange plate of maybe 400 by 30-40 mm, web of thickness around 12 mm, and depth you can calculate, and stiffeners all will be there. This is the beam. Design BM equal to 1500. Right here, very, very dangerous beam. Over. Now, sorry, 4 times pen I am using for beam. Okay, now, one question over. Full beam will sag. Okay. RCC beda. One question over. This is my remove now. Now, question number 2. We are now consider overhang. Now consider overhang. That is, consider overhang. Overhang A on either side. On either side. With what? Either side. Let L, small l be span between supports, or distance between span, either span or distance between supports, say A and B. Now, maintain A less than L by 2 or A less than capital L by 4. Now L is 20 meter, remember, L is 20 meter, okay, by 4. Now I want A to be less than L by 2, so that hogging and sagging and hogging both are there, or BMD required is like this. Scale illa, no scale. So that end portion will hog, middle will sag. Take A equal to randomly 1/4 of 20 is 5 meter. I will not take 5 meter now. I will not take 5 meter. I will take only 3 meter. So that what? 3 meter. Then tell L equal to first. If A is 3 meter, tell first L. I will not show the calculation. L equal to capital L equal to 20. In all the cases, capital L equal 20 meter. All the problems. L equal to ಸದ್ಯ ಯಾರು 17 ಅಂದಿಲ್ಲ, ಅದೇ ಬದುಕದೆ, ಥ್ಯಾಂಕ್ ಗಾಡ್. sometime somebody will tell blindly, sir 17 meter. Abba, overhang of 3 here, overhang of 3 here means 6 gone, 14 meter. Thank you, 14 meter. So that, tell the answer. A by L, what is the answer? Tell me. A by L, what is the answer? Fast. 3 by 14, number. Number ಬೇಕು ನನಗೆ. number should come less than 0.5. ratio of A to span should be less than 0.5. ಎಷ್ಟು? 0.2142. 0.2142 or tell me A by capital L ಎಷ್ಟು? A by capital L. ನಾನು ಇಲ್ಲಿ ವರ್ಕ್ ಮಾಡ್ತೀನಿ, ಅಲ್ಲಿ ಬರಿತಾ ಹೋಗ್ತೀನಿ. A by capital L. A by supported span should be less than 0.25. A by full span should be less than what? Should be less than 0.5. A by what? A by full span should be less than 0.25. 0.15. I will tell you little later what is the meaning of this ratio. ಒಂದು 2 ನಿಮಿಷ ವೆಯ್ಟ್ ಮಾಡಿ. Or my sketch will be, ಇಲ್ಲಿ ಬರಿತೀನಿ ಈಗ. You write all the statement. Example 2 ಬರೀರಿ. Example 2. I will put the sketch here. ರಗಳೆ ಬೇಡ ಇಲ್ಲಿ. ಬೋರ್ಡ್ ಫುಲ್ ವಿಸಿಬಲ್ ಅಲ್ಲ? ಈತ ಫುಲ್ ಬೋರ್ಡ್ ವಿಸಿಬಲ್? ಓಕೆ. ಈಗ 1 2 3 4 ನೋಡಿ, ಸೇಮ್ ಸ್ಕೇಲ್. ನಾವು 3 ಮೀಟರ್, ಇಲ್ಲಿದೆ ನೋಡಿ, ಇಲ್ಲಿದೆ. ಇದು 5 ಮೀಟ್ರು, ಕಮ್ಮಿ ಆಯ್ತು ನೋಡಿ, 3 ಮೀಟರ್ ಸಾಕು. 3 ಮೀಟರ್, ಹಿಯರ್ ಆಲ್ಸೋ 3 ಮೀಟರ್. I want to maintain scale. ಇಲ್ಲಿ 3 ಮೀಟರ್, ಇಲ್ಲಿ 3 ಮೀಟರ್. this will become 14 ಮೀಟರ್. ಇವರು L, ಇವರು A, ಇವರು A. UDL is here. UDL of 30 kilonewton per meter. ಇವರು A, this is B, this is C, this is D. Shearing post diagram I want. 90. Reaction will come. Anybody can tell the reaction here? What is VA equal to? Anybody can tell the reaction? VA VB. Ayyo. 30 into 20 divided by 2. It will never change. Oh, last time question, I forgot to write one thing. You write there. See, last time question, when I wrote 20 meter full span, sorry, UDL of 30 kN per meter, you write the reaction as 300 kilonewton. SFD you write this way, and right there maximum shear force or design shear force is 300 and design bending moment is, actually, how much you got last time? It was 1000. What the answer you got last time? Working load, don't factor now. Design shear force is 300. Okay, 20 into 30 by 2. And maximum bending moment last time, it was 1500. Enter there. Okay, now, bitbidi, last time, here. 90, this is permanently 300. Why? Because total load by 2. Now 90 here, nodi, shear force, only 90 here. here will be 210. See here, higher value 210, 90 ಕಮ್ಮಿ ಇರುತ್ತೆ, 90, 210, here also 210. ಆಯ್ತು ಬಿಡಿ, ಪರವಾಗಿಲ್ಲ, ಎಕ್ಸಾಕ್ಟ್ ಸ್ಕೇಲ್ ಮೇಂಟೈನ್ ಮಾಡಿಲ್ಲ, ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. 210, ಡೋಂಟ್ ಕಮೆಂಟ್ ಆನ್ ದಿಸ್ ಒನ್. ದೆನ್ ಹಿಯರ್ ದಿಸ್ ಈಸ್ 90, this is 90, center is E, special point, ಅಣ್ಣ E, you are special. ಇನ್ನೊಂದು A special, ಇನ್ನೊಂದು B special. ಇವರು E and plus minus come back to 0. Bending moment diagram is, tell the answer, bending moment here 30 into 3 square by 2 hogging. Tell the answer, 30 into 3 square by 8 hogging. What is the answer? 30 into 3 square by 8. See, if you want to understand thoroughly, you should go back to previous all the classes, not suddenly come to this class and tell, hey, that person is not explaining, simply giving formula, leave the class. I will tell, leave my class. You should go through all my classes through overhanging beams. 1500, ಯಾಕೋ ಡೌಟ್ ಇದೆ, 1500 ಹಳೆ ವ್ಯಾಲ್ಯೂ. ಅಯ್ಯೋ, ನಾನು ಕೇಳ್ತಾ ಇರೋದು 30 into 3 ಸ್ಕ್ವೇರ್ ಬೈ 2. ಎಲ್ಲಿದ್ದೀರಿ ನೀವು? ಯಾವ 1500? ನನ್ನ ಕೈಲೇ ಮಾಡ್ತೀರಲ್ಲ. 135 ಈಸ್ ದ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಇಯರ್. 135 ಇಲ್ಲಿ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್, ಇಲ್ಲೂ 135 ನೆಗೆಟಿವ್. ಆ್ಯಂಡ್ ಸೆಂಟರ್ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್, see, I will tell you how you get it. Next time not explaining. WA square by 2 hogging. ಇದು ಅಷ್ಟೇ, WA square by 2. Or you can do one thing, go for basic, minus etc. Formula you can use. Here bending moment. If you want to find the bending moment here, 300 into 7 minus 30 into 10 into 10 by 2. Or use the formula. What? Either you go for basic calculation or use formula, answer will come same. Central bending moment equal to 30 into 14 square divided by 8 minus 135. Is it 600? Is it 600? Illi. Is it 600 here? Nodi, 600 ಅರ್ಧ 300 hogging, hogging and sagging will come this way. 600 maximum. Correct? How you got? Either go for basic calculation or go for formula WL square by 8 minus WA square by 2. Correct? ಈಗ ಹೇಳಿ ಆನ್ಸರ್. Now your design BM ಎಷ್ಟು? Now your design BM ನೋಡಿ, last time it was 1500, suddenly came down to how much? Tell me. From 1500 last time suddenly came down to how much? 600. Means now the depth of the steel beam you may require is maybe around 1 meter, or if it is RCC beam maybe around 750 or 800. Last time you may require depth of 1.2 1.3 meter with the M30 concrete. No. And also tell me, this is a sagging. What is the design shear post now? Last time 300 kilonewton. Design shear post suddenly reduces to how much? See shear post diagram. Just to right of support is the design shear post. Overhang side lesser shear post, inner side higher shear post. From 300 design shear post reduces to 210. Means you can calculate this also. Ega there will be 2 points of contraflexion. Say O1 here, O2 here. I will take this as x1, this as x2. Your x1 will be equal to x2 equal to, I will tell the answer. Can you try later? I will direct tell the answer because I don't require quadratic equation. I know I will look here and directly get the answer. You don't bother. How he is getting so fast? You will try or not? You systematically solve and get the values. Okay, the value will come. .6754 meter. Both of that will come ಇಲ್ಲೇ ಬರೀತೀವಿ ಬಿಡಿ 0.6754 ಮೀಟರ್, ಇಲ್ಲೂ ಅಷ್ಟೇ 0.6754 ಮೀಟರ್. Now I am going to increase the overhang. Guaranteed your design BM is reducing. Guaranteed your design BM is reducing. And point of counterflexure will move inwards or outwards. Tell me. I am increasing the overhang. Point of counterflexure will move inwards or outwards. Common sense. I am making increase in the hogging BM. The points of counterflexure will move further inward. Inward means what? Hogging will increase, hogging region increases, sagging region reduces. What will happen? Points of counterflexure will move further inwards or outwards. Inwards. Okay. Now I will do one thing. Now I will go for full agoytu nodi. Now I will go for ನೋಡಿ ಏನಿದು ಆಯ್ತು ನೋಡಿ ಈಗ 3 ಮೀಟರ್ ಅಲ್ಲ, ಲೀವ್ ಇಟ್. ನೌ ಐ ವಾಂಟ್ ವಾಟ್? ಐ ವಾಂಟ್ ಟು ರೆಡ್ಯೂಸ್ ದ ಸ್ಯಾಗಿಂಗ್ ಬಿ ಎಮ್, ಇನ್ಕ್ರೀಸ್ ದ ಬಡಿ. ನೌ ಐ ವಾಂಟ್ ಅಲ್ಲ, ಯು ವಾಂಟ್ ಎಲ್ಲ maintain a still less than L/2. But now I want reduce sagging BM, because from 600 I want reduce and increase hogging BM till maximum sagging BM becomes equal to maximum hogging BM. Oh, that is that special case of minimizing maximum design BM or maximum BM. Maximum BM. You can tell A should be equal to, I know only total length now. So tell me answer. A equal to, therefore your A should be L by what? Tell me. Your A should be L by number. I cannot connect to small l. I have to connect to capital L. Why? Small l is not known. A should be L by how much? ಬೇಗ ಹೇಳಬೇಕು. ಆಯ್ತು, ಇದಾಗ್ಬಿಟ್ರೆ ಆಗೋಯ್ತು, ಕೆಲಸ ಎಲ್ಲ ಮುಗೀತು. 2 plus root 8. 2 plus root 8 or L should be equal to 20 meter. Tell the answer. Your A should be ಎಷ್ಟು? 20 divided by 2 plus root 8. ಆನ್ಸರ್ ಹೇಳಿ. ಓವರ್ ಆಗಿ ಎಷ್ಟು ಬೇಕು ಹೇಳಿ ಆನ್ಸರ್. ಆಕ್ಯುರೇಟ್ ಆಗಬೇಕು ನನಗೆ. ಒಂದು ಡೆಸಿಮಲ್ ಆಕ್ಯುರೇಸಿ ಮಾಡಬೇಕಾಗತ್ತೆ. ಡೆಸಿಮಲ್ ಆಕ್ಯುರೇಸಿ. ಯುವರ್ ಓವರ್ ಆ್ಯಂಡ್ ಶುಡ್ ಬಿ ಎಷ್ಟು? ನಾಟ್ 3 ಮೀಟರ್. ಇಟ್ ಬಿ ಫರ್ದರ್ ಇನ್ಕ್ರೀಸ್ ಟು ವಾಟ್? ಹೌ ಮಚ್? ಇಷ್ಟೊತ್ತು ಬೇಕಾ? ಎಲ್ ಬೈ 2 ಪ್ಲಸ್ 4.1421 ಮೀಟರ್ ನೋಡಿ. 4.14214 ಮೀಟರ್ ಸಾಕ್ಬಿಡಿ. 214 ಇದರಿಂದ ಜಾಸ್ತಿ ಬೇಡ. 4.142135 ಈ ಥರ ಬರೆಯೋಕ್ಕಾಗಲ್ಲ. 4.14214 ಮೀಟರ್ ಸಾಕು. ರೌಂಡ್ ಆಫ್ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ. ನಾವು ಚೆಕ್ ದಿ ಆನ್ಸರ್. ದೆನ್ ಯುವರ್ ಎಲ್ ವಿಲ್ ಬಿ ಹೌ ಮಚ್? ಟೆಲ್ ಮಿ. ದಿಸ್ ಯು ಹ್ಯಾವ್ ಟೆಲ್. ಇಫ್ overhang is 4.14214, your L will be 20 minus 2 times of A. Answer. Your length, span length between supports should be 20 minus, it answer, full number kodi. 20 minus 2 times of 4.14214. 11.71572. Correct? 11.572 meter. Tell me correct or wrong? ಬೇಗ ಹೇಳಬೇಕು. Therefore, or now do one thing. Apply a check. Tell me your A by L now. ಹೇಳಿ ಆನ್ಸರ್. Your A by L ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ. ಚೆಕ್ ಮಾಡಿ. Your A by L now. Now your A by L will come 4.14 214 divided by 11.71572 ಎಷ್ಟು ಬಂತು ನೋಡಿ. ಅಯ್ಯೋ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಆನ್ ಆಗಿಲ್ಲ. ಅಬ್ಬಾ ನೀವು ಹೇಳಿ, ವಾಟ್ ಇಸ್ ಯುವರ್ ಎ ಬೈ ಎಲ್ ವಿಲ್ ಕಮ್. ಎ ಟು ಸ್ಮಾಲ್ ಎಲ್ ಬೇಗ ಮಾಡಿ. 4.14214 divided by 11.7157 ಬೇಗ ಮಾಡಿ, ಟೈಮ್ ಇಲ್ಲ. 0.3553 ಓ 0.3553 ಅಲ್ಲ 53 ಅಲ್ಲ 0.353553 ಟೈಮ್ಸ್ ಕರೆಕ್ಟಾ? 0.353554 ಬಂತು. 53 ಮಾಡ್ಕೊಳ್ಳಿ, ಯಾಕೆ ರೌಂಡಿಂಗ್ ಆಫ್ ಮಾಡ್ತಾ ಇರೋದು. ಓ ಉದ್ಗಾರ, ಓ ಕರೆಕ್ಟ್ ಆಗಿದೆ. ಸೊ ಫಾರ್ ದ ಪರ್ಟಿಕ್ಯುಲರ್ ಕೇಸ್, if you connect A with the full span, it is around 0.2 times, and if you connect the overhang with the supported span, which is around 35%, that is 20%, there is little more than 35%. Clear or not? With respect to full span, it is around 20%. With respect to supported span, it is around 35%. Clear? Now I will tell you what is this one. See, for example, imagine house rent is 20,000 rupees. Some rich person, not very rich actually, somebody who is going for a what? Comfortable life. He got a house rent of 20,000, and this is your small L. For him, electricity bill, that is overhang, electricity bill is around 35,000 ಬೇಕು 35, around 7,000 rupees. Why? He uses lot of AC, 24 hours all the rooms are AC. He uses electricity up to 7,000. Tell me, the percentage of electricity bill referring to house rent, how much? Answer. Percentage of electricity bill referring to house rent, tell the answer. Percentage. What percent of house rent he is going for his electricity bill? What is the percentage of his electricity bill is what percent of house rent? 35%. ನೋಡಿ 0.35. Now ಒಂದು ನಿಮಿಷ 7,000 ಹೇಳ್ತೀನಿ. Now I will do one thing now. Divide by, imagine his complete house expense, complete monthly expense is 35,000 rupees. Means what? 20,000 house rent, 7,000 electrical, 27 ಆಯಿತು, 8,000 for food. That's all. So somebody will ask, sir, only 8,000. Yes, he does not eat too much. Otherwise, he will go for hotels. In the house provisions, he spent 8,000. So now tell me, now if you connect the 7,000 with the house rent, it is 20% of the rent. Whereas if you connect the current bill with the total monthly expense, including house rent, electricity bill and food item, tell what percent? What percent? Tell me. What percent? ನೋಡಿ ಎಷ್ಟು ಬರುತ್ತೆ ಅಂತ percentage. What percent? His electricity bill is 35% of the house rent, or his electricity bill is full monthly expense 20%, 0.2. ಕರೆಕ್ಟಾ? ಅಷ್ಟೇ. ಅರ್ಥ ಆಯ್ತಾ ಈಗ? ಕ್ಲಿಯರ್ ಆರ್ ನಾಟ್? ವಾಟ್ ಇಸ್ ದಟ್ 0.35 and 0.2? ನೌ ಕ್ಲಿಯರ್? ಬೇಗ ನೌ ಕ್ಲಿಯರ್ ಆರ್ ನಾಟ್? ವಾಟ್ ಈಸ್ ದ ರಿಲೇಷನ್? ಎರಡು ಒಂದೇ, both are same. Okay, now all I am removing now, this full I will remove. Okay, go for diagram. How much? Beam of span 20 meter, overhang is ನೋಡಿ 5 ಅಲ್ಲ, ಸ್ವಲ್ಪ ಕಮ್ಮಿ, 4, ಇದು ಎಷ್ಟಿದು 11, 5, 10, ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಆಯಿತು. ಇಲ್ಲಿ ನೋಡಿ ಈ ಥರ. ಈಗ overhang is ಎಷ್ಟು? 4.14214 meter. Illi overhang is 4.14214 meter, and the span between support is 11.71572 meter. UDL 30 same. Even now reaction will be 300 kilonewton. Sorry, I am not writing 300. Now SFD will come. If you draw SFD now, you can try 30 into 4 little more. A B C D you write. Nanu bere kalsa ide. Ide kalsa madakagalla. A B E. Okay. This is, it will go to 124.2642, then it will jump to 175.7358. Same here also 124. Itara 124 point something, 175 point something center. Therefore, your design shear force maximum, it further reduces to 175.734, and the bending moment diagram will be, you calculate, nanu bere kalsa ide, you calculate correct agi, something wrong, I can make out something wrong. It will come to, what is happening, calculator? $257.36. Here also 257.36. Here also 257.36. What is scale? Oh, this way. Now you can tell, oh, this is what? This is the unique case of maximum sagging BM equal to maximum hogging BM. So design BM here is 257.36. Further less you cannot make. 2 counterflexure point will come. I told you they will move inwards. Now your x1, x2 will come. I will calculate. You try later. Etadu? Is 175 point? And because 4.14214 minus 300. 4.14214 into 30 minus 300 is 175.7358. That number required for me. Now counterflexure point will be it will go further 1.71573 meter compared to last time. See, it was point something, it is moving further. Okay, this is our unique case of maximum sagging BM equal to maximum hogging BM. Tell fully clear? Fast. I have not taken any break today because I want to finish fast. Fully clear or not? Clear. Okay. Now I won't waste time. Now fast I will write another 2 cases. Time better. Now I will do one thing now. Now I will dictate here and write. You try it. I will dictate here and write. You try it. Okay. Now no explanation further. Now I will increase the overhang slightly. Total length is 20 meter. You get 4 point something. I will not go to 5 meter. I will go to 4.8 meter. Still I will maintain the ratio within 0.5. 4.8 meter. This bantu. Scale beda iga parvailla. Overhang 4.8 meter. And span between support will become will come 10.4 meter. Now I will draw only BMD. Only BMD. Now this BM will come 345.6. This also will come 345.6 and sagging BM will come 60. Oh, lesser. ಸರಿಯಾಗಿದೆಯಾ? It is 405. ಕರೆಕ್ಟ್ ಆಗಿದೆಯಾ? 60 ಅಷ್ಟೇನಾ? ಇರಿ, 30 into 4.8 square divided by 2 is 345.6. ಕರೆಕ್ಟ್ ಆಗಿದೆಯಾ ಅದು? ಯಾಕೆ ಡೌಟ್ ಬರ್ತಾ ಇದೆ ನನಗೆ. ಇರಿ, ಎಸ್ ಕರೆಕ್ಟ್. ಓನ್ಲಿ 345.6 minus 30 into 10.4 square divided by 8. It will come 60, still positive, means, ನೋಡಿ, your hogging is increasing further, sagging is slowly reducing, so only 60. Now this is the design BM. Contraflexure point will further go inside, distance will be now is 144 minus 300 is. ನಿಮಗಿದೆಲ್ಲ ಬೇಡ, ಯಾಕೆ ಅಂತ ನಿಮಗಿದೆಲ್ಲ ಬೇಡ. It will go further to 3.2 meter, approaching the center, and still your A is less than L by 2 or K is less than L by 4. Okay. Now go to a case of A, scale ಬೇಡ ಈಗ, ಜಾಗ ಇಲ್ಲ, no space here. Your A is exactly equal to L by 4 or A equal to L by 2. Then unique value, anybody can tell, this is 5 meter, this is 10 meter, this is 5 meter. Now what will happen is your BMD will come, illi 0 will come, it will come this way. Now this BM is 375 kilonewton meter. Okay. Now there is no point of contraflexure, BM 0. Now I will go further when I will take A more than L by 4 or A more than L by 2. Say for example, available space, I will go for 8 meter span here, overhang, I will go for 8 meter. This will become N to N 16. I will go to 6 meter here, I will go to 6 meter here, or 12, this is 8 meter. Horrible case. Now my hogging will severely increase, sagging will vanish, center of beam also will come. What? Tell me. This sagging will vanish. Now center of beam also, what BM will come? Center of beam also, what BM will come? Sagging will vanish. Overhang is super now. Super boss, hogging. Now your BMD will come. SFD, you draw. Six, 540. Here BM will come. Negative only 300. Now BMD will come this way and this way. Somebody may comment, ಸರಿಯಾಗಿ ಡ್ರಾ ಮಾಡಿಲ್ಲ. My answer is come in front of me. Any comment, because I was standing here, see, little tilted. Important is concept. Anybody commenting on ಇದು ಜಾಸ್ತಿ ಕಮ್ಮಿ ಸರಿಯಾಗಿ ಬರೋದಿಲ್ಲ 540 ಕೆಳಗೆ ಬರಬೇಕಾಗಿತ್ತು, ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಬರಲ್ಲ ಅವ್ರಿಗೆ ಅಂದರೆ ಅವ್ರು ಒಂದೇ ಆನ್ಸರ್, ತಾಕತ್ತು ಧೈರ್ಯ ಇದ್ದರೆ ನಾನು ಮುಂದೆ ಬನ್ನಿ ಅಷ್ಟೇ ಕನ್ನಡದಲ್ಲಿ. ಸಾರಿ, ಐ ಶುಡ್ ನಾಟ್ ಟೆಲ್ ದಿಸ್ ವೇ. ಅಷ್ಟು, if you are commenting that way, comment in front of me. Those who are knowing me, they know what I will do for them, not physical activity. Okay, leave it. I don't bother about such things, because even time is not there, some gap is there here. Once you understand these things, sometimes when I focus on the board, see, you can see other things here. People will not do that way. They will go by a app they will set before live streaming. They will tell other things they do not want. That is called show off. I never go for show off. Thumbnail. Nobody will write in a pen. They will go for printed thumbnail. I know by going to printed thumbnail, it attracts more views. No, I do not want people to come visit my class or see my class because of show off. They should see, go through it because of the content or value. Okay. Now fully clear? Tell me. If fully clear, over, next class I am going to cantilevers. That is tomorrow we are starting cantilevers. Correct time match aaytu nodi 1 hour. If full clear, tomorrow we are going to cantilever. Very important. Lot of concepts are there for cantilever. Not simply W square by 2 or find bending moment. There are lot of concept in cantilever. Clear? Okay. Thank you. We will meet tomorrow. We will start cantilever. I will give so many information for cantilever for you tomorrow. See that those who attend the class or live is still better. Your all doubt for cantilever I will remove and make it fully clear. Okay, thank you.